so we're on section R.4 now. We're going to talk about factoring in this section. And so factoring is similar to dividing. You could think about it as dividing. You're trying to unmultiply things that are grouped together and put them into their parts, into their prime parts. One way to think about it is if I said to factor the number 12, you could break that down. Some people use factor trees and say that's 6 times 2. Then the 6 can be broken down into 3 times 2 until everything is a prime part. So factoring, you should get it all the way down to where each part can't go any further. The only thing that goes into it at that point is 1. So we could write 12 as 2 times 2 times 3. And that would be factoring just from an arithmetic standpoint. But we factor in algebra, we factor polynomials as well, and sometimes it's a little more complicated to try to figure out the combo before it was times. So let's get started. R.4 example 1, we've got a polynomial, just a 2-termer. The first thing you want to do whenever you're factoring a polynomial is factor out the GCF. If there's a common factor that's throughout all the terms of the polynomial, you want to factor that out. So for y5 and y2, there's a common y to the second that can be factored out of that, leaving 9y to the third plus 1. And you do need to show that 1. So we should always be able to multiply this back together and get back to this. It should be equivalent. Y squared times 9y to the third multiplies to be that, and y squared times 1 to get back to that. So we're kind of reversing the multiplication. Like I said, factoring is reversing your multiplication. Example B. And then like I said, it should always be prime. If there's anything that will factor further, you should always do that. This one does not, though. We're starting out with examples that just have a GCF, a greatest common factor, to pull out of all the terms. So in this next example, when you look at there's 3 terms, you've got a 6, 8, and 12. Numerically, there's a common factor of 2 that will come out of all those. And then for the x's, there's not an x in all 3 terms, so I can't do the x, but there is a t in all 3 terms, so I can factor out the common t. So you're factoring out what's common to all parts. And then doing the reverse of distributing, saying this times what is this? We need the 3, the x squared. The 2 times t times that will give you everything else you need. Then 2t times what to get the next middle term? And then 2t times what? You need a minus 6 to get the right sign here, and the t is already there. And then sometimes this will factor further, so that's the next thing we're going to talk about, but not yet. So GCF is always the very first step that we take in factoring. There's not always a GCF. It's kind of uncommon. A lot of the examples I see in your book, there's not a GCF. But so it almost makes us forget to look for that. But even if you can unfoil or use another factoring method, GCF is really the first step. Always do that first. You look through all your terms, factor out any common part before you proceed with any other method. All right, the next example, moving over to example 2, is factoring by grouping. So sometimes there's not a common factor in the list of your terms, but if we group it, we can do something productive. So in example 2, we see some that are set up for that. So when I look at these 4 terms, and a lot of times with factoring by grouping, you'll have 4 termers. When you look at your 4 terms, there's nothing in all of those terms. There's not an m in everything. There's not a p in everything. The 7 and 20. There's just nothing common through all the terms. But if I grouped it into the first 2 and the last 2, I could factor it by grouping. Out of the first 2, there's a common m, leaving a p squared plus 7. And out of the last 2, I could factor out a 3, which just by chance, not really, they fixed some of these out so they'd work like this, gives us exactly the same thing in the parenthesis. And that's the only way that factoring by grouping is going to work for us if the problem just so happens that when you group it, and sometimes you have to rearrange it for grouping, but oftentimes it's just the first 2 and the last 2. But if you're able to factor something out of the first 2, something out of the last 2, and then this parentheses is the same, you're going to be able to factor it completely. So you can't leave it like that. You've got to have a matching set. So that's a factor now for these two terms. That's a term, that's a term. There's two terms. And then what's common to those two terms, now the next GCF in this space is p squared plus 7. And then we say p squared plus 7 is times by an m here. And p squared plus 7 is times by 3 here. And then it's completely factored. To be completely factored, you can't have plus and minus signs in it. It has to be a string of prime factors multiplied together. Notice if I FOIL this back together, it should come back to this. So first is that, outer is this one, inner is that one, and last times last is that, so you can confirm it did work. Okay, let's do that one more time on example C. And we have 4x cubed plus 2x squared minus 2x minus 1. So again, nothing common throughout the whole thing, but if I factor it by grouping, on the first two there's a common. 2x squared would be common to both of those, which leaves a 2x to the first, and 2x squared times, you do have to show this 1, because it has to be able to re-multiply to verify it's the same. Now out of these next two, they both have negative signs, and oftentimes you want to factor out that negative sign. See what happens. Negative 1 times positive 2x, and negative 1 times positive 1 would be that. And there now I can see that is a matching set, so that means I can continue with the factoring. So those two are now the common part, so I factor that out as the GCF, and then write the parts that were left, 2x squared minus 1. And then that would be completely factored, prime factors. All right, so that's factoring by grouping. All right, the next thing is the trinomials, and this is the one that's the most common thing that we see over and over again as we go through this course, is having to factor a trinomial. And they're little puzzles for us, and some of my students tell me they just hate these. I mean, a lot of my students tell me they hate this.